Welcome to this explainer on the true cost of NestJS. Today we're diving into a really fascinating question from our source material. Are the exact tools that we use to build backends faster secretly creating massive new problems for us down the line? Let's jump right in. There's this incredible irony in modern web development right now. Years ago, developers were literally running away from the towering, heavy fortresses of enterprise Java. They wanted the lightweight, fast freedom of Node.js. They wanted JavaScript. But if you look closely at what we've been building lately, well, it kind of seems like we unknowingly rebuilt those exact same enterprise fortresses right back into TypeScript. We spend so much time obsessing over how to scale our code bases, but we almost never stop to ask, what hidden operational tools do these new, highly structured frameworks actually demand in return? So, what exactly are we dealing with here? Well, NestJS is a highly opinionated Node.js framework. It leans heavily on decorators, inversion of control containers, dependency injection, and lifecycle hooks. To a lot of experienced backend engineers, it honestly feels less like a native Node.js framework and way more like Java's Spring Boot just translated into TypeScript. And hey, that isn't automatically a bad thing. But the uncomfortable question we really have to ask is, do Node developers fully understand the trade-off they made when they adopted all these heavy enterprise patterns?
To really understand why this happened, we've got to acknowledge the very real pain of what came before it. Express.js gave developers enormous flexibility, right? But it gave almost zero architectural guidance. As Node teams grew, codebases just became wildly inconsistent. Middleware chains became completely unpredictable. Onboarding a new developer into a massive, unguided Express codebase, it felt like stepping into the Wild West. Finding a highly structured solution didn't just feel like a nice-to-have, it felt absolutely necessary just to survive the spaghetti code.
Okay, let's dive into this contrast. On one hand, you have the tangled spaghetti bowl of Express.js. Super flexible, for sure, but completely unguided and highly inconsistent across large teams. But then, NestJS arrives, and it's like a rigid, perfectly organized office building. Suddenly, Node applications had structure. They had centralized dependency injection. They enforced architectural consistency. For engineering managers, this was an absolute dream. NestJS genuinely improved the developer experience, and it really reduced that organizational chaos by forcing everyone to play by the exact same structural rules. But right here is where the story gets a bit complicated. Because the problem isn't that NestJS is poorly designed. Actually, it's designed incredibly well for what it tries to do. The catch is that it inherited an entire philosophy of backend engineering that comes with some serious hidden operational and architectural costs. This organized bliss, this beautiful predictable folder structure, it brings some really heavy underground machinery with it once a code base actually starts to scale up in production.
It's wild to think about the maze that a single, supposedly simple request has to navigate. A request enters at the controller. Then it jumps over to a guard. Next, it drops down into pipes to validate the data, bounces through interceptors that wrap the execution, and finally, hits the services orchestrating the logic. Oh, and we aren't even done yet. Then it has to go through repositories and DTO mappers. Technically, sure, every individual layer might be justified, but collectively, the execution path is just completely fragmented. A simple request is literally no longer simple.
Which brings us to a really fascinating quote from our source material. Tracing behavior now requires framework knowledge. Debugging becomes architecture dependent. Think about that for a second. Debugging a single request now means you're navigating multiple decorators, metadata layers, and lifecycle hooks before you ever even touch the actual business logic. This cumulative weight of abstraction basically means your developers are spending way more of their mental energy navigating the framework's orchestration than they are actually understanding the business problem they're trying to solve. And we're not just talking about cognitive load here. These are real, physical runtime tools. NestJS relies so heavily on reflection metadata. At startup, the framework has to scan modules, then analyze metadata, then resolve complex provider graphs, then initialize lifecycle hooks. This literal runtime machinery stacks up fast. We are talking about increased cold starts, much higher memory usage, way slower application bootstrap times. It's a massive amount of heavy processing overhead just to get the application ready to accept its very first request. Now, context is absolutely everything here. Think of a traditional, long-running monolith as a massive cargo ship. Teams can usually tolerate these heavy initialization costs because, well, the engine just keeps running. But if you drop this heavy machinery onto a serverless speedboat, oh man, it becomes a serious liability. Plus, because NestJS hides so much runtime behavior behind these abstractions, performance profiling becomes incredibly difficult.
Your hot paths are fragmented across all these framework-managed layers, which makes it almost impossible to figure out where a bottleneck actually lives. To really wrap our heads around this, let's ground the theory in reality. We're going to look at a realistic case study of a growing SaaS company to see exactly how this framework traps springs in the real world. This is basically the story of how a completely rational architectural choice slowly compounds into an absolute operational headache over time.
Let's track how this builds up. Month 1. That's the honeymoon phase. The project structure is super clean, controllers are organized, and new developers onboard super fast. But by month 6, the system grows. You've got expanding dynamic modules, shared providers, and global interceptors just accumulating. Fast forward to year 1, and suddenly production latency issues start appearing. The team discovers rising memory usage and slow startup times caused by massive dependency trees. By year 2, simply making a minor feature change requires touching a dozen different files across the container. The team isn't even navigating business logic anymore, they're just navigating framework orchestration.
I really want you to ask yourself this psychological question about your own engineering teams. When there's a bug, are your developers asking, what is the code doing? Or are they forced to ask, how is NestJS executing this? Because the exact moment your team shifts from that first question to the second, framework abstraction has completely dominated your engineering behavior. The very tool you adopted to make things simpler has ironically become the primary source of your complexity. It's so fascinating to see how perspective shifts with experience. Beginners usually look at frameworks and optimize for immediate productivity and developer ergonomics. Does this feel good to write? But senior engineers, the ones digging into the roots of the system, they evaluate frameworks as a fundamental runtime architecture decision. They're optimizing for system behavior under scale, operational visibility, and long-term maintainability. They absolutely know that every single abstraction introduces a real runtime cost. So they evaluate the tool based on what it does to the hardware, not just how pretty the folder structure looks. So the absolutely crucial point is this. Organizational consistency is not the same thing as engineering simplicity. A framework can absolutely give you beautiful, predictable folder structures. It can force every team to write code the exact same way, and it can genuinely reduce organizational chaos. But that does not mean it is a lightweight, efficient, or simple runtime architecture. You can have a perfectly organized code base that is literally an absolute nightmare for the CPU to actually execute. So, how do we escape this? Well, we need to return to the principles of proportional architecture. A truly good backend system prioritizes clarity way before abstraction. We want a clear request flow where execution is explicit, right? Not hidden away behind layers of metadata. We want runtime transparency so we can actually see what the event loop is doing at any given moment. We need measurable performance and, above all, operational simplicity. Framework structures should exist to solve real existing business complexity, not to manufacture unnecessary layers of enterprise ceremony before that complexity even exists. NestJS definitely gave Node developers the enterprise structure they thought they needed. But in doing so, it imported the exact architectural habits they originally tried to escape. The question isn't whether this framework is objectively good or bad. The real question you must ask yourself today is this. Does your specific system actually benefit from the massive architectural weight it introduces? Because every abstraction you adopt eventually becomes your operational reality. Choose them wisely.